go ahead and go over our lesson objectives before we begin. After this lesson, I want you guys to be able to define a ratio, define a proportion, use ratios and proportions to solve problems involving two or more items, and lastly, describe several real-world examples and applications of ratios and proportions. So let's go ahead and dive right in. First of all, what's a ratio, right? So a ratio is a way to compare two items that have a relationship between them. Now, this relationship is not going to be adding or subtracting, it's going to be a multiplicative one. So basically, these two items can be compared. One is 2 times or 3 times or 4 times more than the item. And we'll get into more of that in a second. But pretty much again, we're comparing two items. So for example, let's go ahead and say that there's one boy for every 2 girls in a certain context. So the ratio, we can go ahead and state it like this. 1 column 2. That means 1 to 2. We can also write it as a fraction, 1 over 2. And so yes, if that's a question you had, fractions are ratios. But again, when we name these ratios, when we name 1 to 2, if that 1 came first in the sentence and 2 came second, then we need to write the 1 first and the 2 second. Make sure that we do that always. And another important fact to add is that two ratios can be written differently, but can represent the same exact ratio. So again, ratios can be simplified if their values share common factors. So let's take this for example. If we're comparing 3 to 6 and 1 to 2, these are the same. Intuitively speaking, let's think about it this way. 3 is half of 6, right? 1 is half of 2. So in that sense, yes, they are the same exact ratio, just written differently. Another way to confirm this is like this. 3 and 6, what common factors do they have? Well, 3. 3 can divide into 3 as well as 6. So let's go ahead. 3 divided by 3, what's that? That's 1. 6 divided by 3, well, that's going to be 2. So the equivalent ratio of 3 to 6 is 1 to 2. Notice that I didn't mess with the 1 to 2 because it was already in simplest form. However though, if I wanted to go forward, because I kind of went backward here, I could go forward from 1 to 2. Notice, if I wanted to get from 1 to the 3 that was here, 1 times 3 is 3. So if I multiply by 3, I get 3. And whatever you do to one side of a ratio, you should always do to the other. So 2 multiplied by 3 is 6. And so we proved it both ways. 3 to 6 is the same as 1 to 2. So let's go ahead and move along here. So, equivalent ratios. Let's go over this example. Which of the following ratios is equivalent to 1 to 4? And let's go ahead and select all that apply. There are multiple answers here. Could be 1, could be 2, could be all 5. Let's check it out. So, we're going to have to go through all of our answer choices and basically use a process of elimination. Let's go ahead and change slides so we have more space to work with. Let's start off with answer choice A, 12 to 48. 12 to 48, well, again, just like we did in the last slide, in that last example, we want to go ahead and basically find which common factor we have and then reduce it. Because 1 to 4 is already in simplest terms. So, 12 to 48, off the bat, I know that 4 goes into 12 and 48. So I can go ahead and divide 4 out of both of these. 12 divided by 4, that's 3. 48 divided by 4 is 12. Now, just because you've reduced the ratio once does not mean that that is the last stop. Make sure that you go and reduce it to its simplest form. Here's what I mean. 3 to 12, that can still be reduced. 3 and 12, what do they have in common? A 3. Divide both by 3, and we'll get 1. 12 divided by 3 is 4. That works out just fine. So actually A is one of our answer choices. Select all that apply. There are multiple answers here. 3 to 15. Go ahead and check that out. I'll start that one right down here. I'll use red here. 3 to 15, well, what do they have in common? I already know that this isn't the answer because 3 to 12 was 1 to 4. 3 to 15, it won't be. Well, let's go ahead and prove it. Divide both by 3 because 3 is a common factor of 3 divided by 3. 15 divided by 3 is 5. Is that correct? For the correctness of the problem? Nope. So B is not an answer choice. Look at C. 8 to 2. I'm going to remain using red here. Let's write 8 to 2. Well, all right. Both of these numbers have a common factor of 2. So let's divide them both by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. Now that ratio is 4 to 1. That is not the same as 1 to 4. Remember earlier in our notes, we said that they have to be written in order. 4 to 1 is not the same as 1 to 4. So C is not an answer. Let's check out 1456. I'm going to change the screen over here. Hopefully we can see this. So 14 to 56. Now, what do they both have in common? Well, check it out. I can go ahead and divide both of these by 2 because they're even. I'm going to take the easy way out. Both even numbers, divide them both by 2. 56 divided by 2 is 28. This is great. I already know that this is the answer because 7 times 4 is 28. If I divide both by 7, that's 1 to 4. Because 28 is 4 times 7. So D is an answer choice. Now let's take a look at E. Let's use black here. 10 to 25. Is 25 10 times, or 4 times 10? I don't think so. Let's go ahead and prove it though. What do they both have in common? Well, they both have a 5 in common. Divide both by 5. And we get 5. That's as close as we can get. E is not the answer choice. So, finally, that took a while, but A and D are the correct answers. So hopefully that gives us a better understanding of ratios. Let's go ahead and move right along here. Another practice problem. So, a particular recipe calls for 15 tablespoons of salt for every 20 cups of chicken broth. So which of the following scenarios models an equivalent ratio? So, before we even answer this question, before we look at our answer choices, let's think about what we're looking at. Let's give ourselves some more room here. So, key words here. Let's make sure we read the problem carefully. 15 tablespoons of salt for every 20 cups of chicken broth. So if we were writing the ratio, if we were representing this ratio, the way we would write it would be 15 to 20. And there we go. So, we got two options here. We can go ahead and see which of these will be 15 to 20, or we can notice that here, 15 to 20, we can reduce that. Let's put it in simplest terms. That way we can have an easier time here. So, 15 to 20, this is going to be the ratio 3 to 4, and here's why. Both 15 and 20 are divisible by 5. So if I divide both by 5, 15 divided by 5 is 3. 20 divided by 5 is 4. So there we go. The ratio that we're looking for is 3 to 4. So let's go ahead and read through these scenarios and find out which of these is a ratio of 3 to 4. A. John bikes 4 miles each time Jerry bikes 7 miles. Okay, so for A, that ratio is 4 to 7. We can't really reduce this. That's as simple as it can get. That's a pretty easy one there. It's not the answer. B. 2 microphones where one is 9 inches tall and the other is 12 inches tall. Let's check it out. 9 to 12. Can we reduce that? Can we reduce that? That is the big question. And the answer here is yes. Both 9 and 12 both have a common factor of 3. So let's divide both by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. And there we go. Mic drop. No pun intended. Answer is B. All right. C, D, E. 4 slices.
Why'd you say mic drop?
Pun.
Because it's
2 microphones.
What? Why'd you laugh? You looking at me like...
I felt you just...
Oh, how are you going to do this now? You going to start over with it?
No, we'll just phase it out.
Just start with
Yeah.
C?
Yeah.
Okay.
And so there we go. We found the answer. The answer choice is B. This isn't a select all that apply question, so there's no need for us to search through C, D, and E. But I'll go ahead and take a quick second and just work with C for a second. C, 4 slices of pizza cost a total of $3. That ratio would be 4 to 3. Again, guys, the order matters. 4 to 3 is not the same as 3 to 4. That's why C isn't the answer. I'm purposefully putting these questions and answers in there so that we can really get to know this concept as a whole. D, for after 18 minutes, a car travels 6 miles. If we wanted to go ahead and represent that, 18 to 30, I'm going to go ahead and cheat a little. They're both even, divide them both by 2. That's 9 to 15. Both divisible by 3, that would be 3 to 5. Not what we're looking for. And E, a 20-ounce box of cereal costs $5. I already know that that would be the answer because we need a smaller to bigger, 3 to 4, not bigger to smaller. So we can use some context clues there. We're fine. And there we go. That's why the answer choice is B. So let's go ahead and start talking about proportions now. This is important. Proportion is basically an equation that just compares two ratios. But here's the thing. The ratios have to be the same. They can be presented differently, but they are equivalent. Make sure that that's in mind. So an example would be 1/2 equals 3 over 6. These are equivalent ratios. 1 is half of 2, 3 is half of 6. So let's go ahead and dive right in. Some word problem tips before we begin. So when you're setting up proportions, you need to make sure that the ratios you equate represent the same comparison of items in question. So let's go ahead and dive into a problem here. Because when there's context involved, that's when you can maybe switch the order around a little bit when you're talking about proportions. So here we go. The ratio of boys to girls at an elementary school is 1 to 2. There are 20 boys and 40 girls. Write the proportion which models the scenario. So 1 to 2, I can go ahead and represent that as 1/2. And I can say that this equals 20 over 40. Now, here's why this makes sense. First of all, the ratios are equivalent. 1 is half of 2, 20 is half of 40. Another thing, the ratio of boys to girls. 1 represents boys, 2 represents girls. The ratio of boys to girls. 20 boys, so this is the number of boys, and this is the number of girls, 40 girls. And so that would represent girls. So hopefully we can see there that in both numerators, we're comparing the boys. Both denominators, we're comparing the girls. And notice that on the left side, this left side ratio, this is the ratio of boys to girls. The right side is the actual boys to girls. So as long as we compare them in the same way, we are good. Hopefully we can see that there. So let's go ahead and dive right into the next problem. Not next problem, but before we do, some tips. So when you're solving a missing item in a scenario which involves proportions, which is very likely for you to do, first off, identify the missing pieces of information with a variable. Whatever you don't know, mark it with a variable. Be X if you're always comfortable with that, or use the letter of what we're talking about. B for boys, G for girls, whatever you want. Next, set up the proportion which represents the problem. Make sure you represent it correctly, because afterwards, you're going to go ahead and solve for that missing variable. And it's easiest to tackle cross multiplication, but there are other methods, and I'll go ahead and go through that. So, an example of proportions. An athlete bikes 3 miles for every 2 miles he runs. If he ran 10 miles, how far did he bike? So let's go ahead and see what we got here. And an athlete bikes 3 miles for every 2 miles he runs. We can go ahead and say 3 miles bikes for every 2 he runs. Bike and run. Alright. And we need to go ahead and equate it to an equivalent ratio, guys. So it says here, if he ran 10 miles, alright, be careful, ran 10 miles. Which one? The numerator denominator represents running. Our denominator. 10 belongs there. That's the important part about setting up proportions. In the numerator, well, we're being asked, how far did he bike? So we can represent that with a variable. And so we're asking how far he biked. I'll just use B for biked. Hopefully that doesn't look like a 6. I think my handwriting's all right. So, like I said, if we're solving for that B, the easiest way to go about it, or the safest way, would be cross multiplication. All right? So b times 2, that would be 2b. 3 times 10, that would be 30. I have my equation set up. 2b equals, I want to get b by itself, since I'm multiplying by 2. Let's divide both sides by 2. And that would mean b equals 15. Boom. There we go. So b 15, that means that the athlete biked 15 miles. All right. So here's another way we can think about it. If he runs 2 miles and bikes 3 for every 2 that he runs, well, that's about 1.5 times. You can use some intuition there and say, hey, what's 1.5 times 10? 15. So once you start building this skill up, you're going to start noticing some patterns that you can go ahead and use to make yourself more efficient. Remember, guys, you're taking an exam, you need to pass in a certain limited amount of time. Make sure you not only know the concept, but practice enough to where you can go ahead and circumvent some of these processes and get these problems done much quicker. All right, so let's go ahead and take a look at this first practice problem. So this is one of the questions that we get, so pay attention closely here. A bag of marbles contains 7 red marbles for every 5 green. If the bag contains 98 red marbles, how many green marbles are contained in the bag? All right, here are our answer choices. I'm sure you use them. So let's go ahead and set this bad boy up. Let's get information first. 7 red marbles, every 5 green. There are 98 red. How many green? Being asked to find how many green. I'll go ahead and use G for those green marbles. Sound good? Cool. So let's go ahead and set everything up. 7 red for every 5 green. 7 red for every 5 green. It's going to be equal to 98 red that are total amount of red for that certain amount of green. So let's check it out. This is how I set up my proportion. 7 up top, red. 98 up top over here, also red. This is the ratio, 7 to 5. This is the total, or the exact amount, 98 to G. I know that my proportion is set up properly. It's not all funky, so I'm good to go. So, again, the easiest way is cross multiplication. This is a little harder to use intuition with, just because 5 to 7 is not a common ratio that we deal with on a daily basis. So, let's go ahead and cross multiply. 7 times G, that is 7G. Then we have 98 times 5. So 98 multiplied by 5. All right, so what this means is that 7G, and if I do this properly in my head, that's going to be 490. All right, so 7G equals 490. If we divide both sides by 7 now, that's going to be G equals 70. And there we go. So there are a total of 70 green marbles in the bag. Boom. And that's answer choice C. So hopefully, again, we're getting a little sense out of this. We want to feel a little more comfortable each and every time. But let's go ahead and dive right into our second example problem, which is the second pre-quiz question that you dealt with. A study conducted in a certain city found that 4 in 9 people exercise regularly. If 7,680 people exercise regularly, how much of the population does not exercise regularly? All right, cool. So here is where we're going to need to be very, very, very careful about our setup, because this is why marking your information is important. First off, let me go ahead and just keep it here for a second. So 4 in 9 people exercise regularly, okay? 4 in 9. We can say that that's a ratio. We can say, hey, 4 to 9 represents exercise to the total population, because 4 out of 9. 9 represents the total. But think about what we're asked to find. We're asked how much of the population does not exercise regularly. We don't want to compare it to the total. We want to compare it exercise and not exercise. So how do we do this? Here's the thing. If 4 in 9 exercise regularly, that means that 5 out of 9 don't. So this actually is not the ratio we want to use, not 4 to 9. We want to use the ratio 4 to 5. And again, let me go ahead and slow it down there, because I really want to make sure we got this. Again, 4 out of 9 exercise regularly. That means that, well, how many are left? Well, 5 to get to 9. So 4 exercise regularly and 5 do not. That will make the total of the out of 9, or 4 out of every 9 persons. So again, the true ratio is 4 to 5. Hopefully I didn't trick you, but if I did, it's a learning moment. Okay? So 4 to 5 is what we're looking at, because that's what we're trying to find. If 7,680 people exercise regularly, because it's on the left side, because 4 is exercise regularly, 7,680 will be on the left side again. And again, let's just pick a variable. Does not exercise regularly. I'll go ahead and just use X for the sake of keeping things simple. And there we go. We just want to go ahead, equate these two ratios, and solve. Let's go ahead and do it. So again, 4 to 5 is going to be equal to 7,680 over X. We solve this, and we're good. So, like always, keep it safe. Cross multiply, eventually you'll get quicker at it. 4x equals 5 times 7,680. I'm going to go ahead and grab my calculator because 4 digits is a little ugly. So 7,680 multiplied by 5, that gives us 38,400. Lastly, we see that our variable, what we're trying to solve for, is multiplied by 4 to get that number. Work backwards, divide by 4. Gone. X equals, I'll divide that number right here by 4. That gives me 9,600. And there we go. Answer choice C. Awesome. So before we go on to the next question, I think it's important for us to know that we may have gotten, I believe, 18,000, which is the incorrect answer. We may have gotten 18,000 if we would have set up the ratio 4 to 9. But again, I believe I answered that question, but let me just reiterate it. We were comparing exercise to not exercise to the total population. That's why we use 4 to 5 and not 4 to 9. All right, last practice problem here. The last pre-quiz question. Hopefully we're doing all right so far. In a neighborhood pond, the ratio of fish to turtles is 11 to 2. If the ratio, or if the number of fish and turtles combined is 1,066, determine the number of fish in the pond. And this is one of those questions in the Praxis exam that you will be asked to just write the number out or type the number out on the test. So let's go ahead and collect our information here before we move on to the next screen. Ratio of fish to turtles is 11 to 2. Wow, that's a gift in itself. Fish to turtles. So make sure this is F and this is T. Fish, turtles. Left, right. Fish, then turtles. All right. If the number of fish and turtles combined is 1,066, determine the number of fish. So we're looking for F. That's what we're looking for. But this number right here, we got to be a little careful. Here's why. That represents neither fish nor turtles. That's the combination of the two. So we have to be very careful about how we approach this problem. Very, very careful again. So we're looking for F. Just make sure we know that. So we have 11 to 2. So we can go ahead and write 11 over 2 equals fish to turtles. That's a problem, right? Because we have two variables here. There's no way we'd be able to solve for this. But here's how. I'm going to show you guys a little trick here. If the ratio is 11 to 2, well, that means that the total number of parts that we're dealing with could be 13. 11 plus 2. Fish, turtles. We got 13, all right? The total ratio there. Now, the total is going to be 1,066. So we can actually compare this 13, so the total ratio, to the total critters here. 1,066. So, is 1,066 divisible by 13? Can we reduce this? Let's check it out. 1,066 divided by 13. Let's check that out. And it does. It's 82. This turns to 1. 13 divided by 13 is 1. 1,066 divided by 13 is 82. All right? So what that means is that every 1 represents 82. we have 11 to 2. So 11 times 82 will give us the total number of fish. And 2 times 82 will give us the total number of turtles. And this is going to make total sense in just 1 second. Watch this. 11 times 82, let's see what we got. That gives me 902. So 11 times 82, which means that there are 902 fish. And that's going to go right here. That's our answer because we're looking for fish. 2 times 82 is turtles. That's 164. Right? If we add these two together, 902 plus 164, 2 plus 4 is 6, 0 plus 6 is 6, 9 plus 1 is 10. That's 1,066. 1,066 total critters. It's all about how we interpret these proportions, guys. And so we did have to do a little more work there. And these are one of the more difficult problems you'll deal with proportions, where they give you the parts and they ask you to compare it to the whole. So hopefully we got a lot out of this lesson today, guys, because we have one more practice problem to go. The ratio of the cost between socks, shirts, and pants at a clothing store is 1 to 3 to 4. If the total cost of purchasing one of each is $36, determine the cost of each item individually. All right, so again, this is the same type of problem as practice 3. This was not included in your pre-quiz because we want you guys to go ahead and go over all of these videos. So look, let's check it out. The total cost, $36. They're not giving you the individual items. They're giving you the total, $36. The ratio that you're given, you're comparing 3 items this time. We can't exactly use a fraction here because you can't do 3 types. But we have 1 to 3 to 4. How many total parts is that? Well, 1 plus 3 is 4. 4 plus 4 is 8. So what that says is this, the 8 total parts, can be compared to the total price of $36. That's what that means. So, can we go ahead and figure out what one part would be? What that would mean for us to do is divide both sides here by 8. And since we're dealing with money here, we're okay with using decimals. So keep that in mind. 8 divided by 8 is 1. 36 divided by 8, go ahead, use your calculator. 36 divided by 8 is 4.5. So what this means is that every one part represents $4.50. Let's use money there. Every part is $4.50. So, socks, shirts, pants. Socks, shirts, and pants. All right. 1 times $4.50. Well, $4.50. So my answer for socks is just $4.50. I got 3 of those parts representing shirts. So 3 times $4.50, what's that going to be? That'll be $13.50. Again, I take the 3 here, multiplied it by 450 because there are 3 parts. So it's going to be shirts. One shirt will cost us, again, $13.50. Let's use that calculator just to confirm. I'm pretty confident about that. I'll cry if not. So let's see. Yep, $13.50. And lastly, each pair of pants. Each pair of pants, well, we'll take the parts, so 4 parts, multiply it by the worth of each part, $4.50, and that will give us $18. And there we go. We got the cost of each. So what I did again was combine the parts together because the total parts compares to the total cost. Compare the ratios in the same way. So add these all together. What do we get? We should get 36. Grab your calculator. It does. $4.50 plus $13.50, that's $18. Plus 18 again, that's 36. And there we go. We have now found the cost of each. So let's go ahead and review. I know this was a lot to take in, but go ahead and make sure to keep looking at our study guides, flashcard sets, and problem sets. That way you can continue acclimating yourself to this. So what we want you to be able to do is ask yourself the questions. Are you now able to define a ratio? Can you define a proportion? What's the difference between the two? Can you use ratios and proportions to solve problems involving 2 or more items? And lastly, can you describe real-world applications of ratios and proportions? If you can go ahead and say that you're confident in all 4 of these, you're well on your way to passing the Praxis Math exam. So that's it. Make sure to practice. Again, we have our vocabulary sheet, study guides, and practice problem sets for you to use. Make sure you get to it. Make sure you ask us any questions, and we're all here for you. Let's get cracking.